Hi students, coming to the next topic in the subject operating system is paging. So in the memory organization of operating system, so how the paging will be helpful and now let us see. So the paging is one of the concept of the non-contiguous allocation. So I said a non-contiguous allocation. The example for non-contiguous allocation is paging. So this non-contiguous allocation is also called as virtual memory. So this is a concept of virtual memory. Means it is not the real, it is everything is a non-logical. That paging concept, everything is a logical. It is non-contiguous allocation, which is, you call it as a virtual memory. So to provide, so let me write the points for this. Actually, to provide ease to the users and at the same time, to increase the CPU utilization, we use the concept of virtual memory. Why we are using the virtual memory concept in the operating system? To provide easy to the users and at the same time to increase the CPU utilization. To increase the CPU utilization, we use the concept of virtual memory. So in this system, operating system is giving illusion to the user. So just it is giving illusion. It's not a real. In this system, here the operating system is giving illusion to the user such that. So why it is providing illusion to the system? Why the operating system giving illusion means using the concept of virtual memory to the users? Because the user can write a very big program. The user can write a very big program and user thinks that its entire program is present in RAM. So just the user think that the entire program, whatever the program that he is accessing, that is present in RAM. So he is just the virtual, I'm saying about the virtual concept, virtual memory, which is a non-contiguous allocation. So here the operating system is giving just illusion to the users. Why it is giving illusion to the users? Means we are using the virtual memory. User can create a very big program with the help of virtual memories, and also user thinks that its entire program, whatever he is accessing, is present in RAM, and all the space allocated to the user is contiguous. So it is thought that whatever the space that is allocated in the main memory is contiguous, and user address starts from all zeros. So it's just creating illusion to the users by using this point, means to alert that user can write very big programs and users can think to write entire program in RAM. So in reality, only a small portion, only the small portion of the user program is in RAM. So in the RAM, not the entire program is present in the RAM. We are having only just the illusion, means we are adding some virtual memory, but in reality only the small portion, whatever we want to be executed, that small portion of the user program is in RAM with the help of the library functions. So which may or may not be contiguous. So that whatever the data, that small portion that you are using, that may or may not be contiguous, while the remaining program is present in secondary memory. While the remaining program in secondary memory. So if you know this concept, then you can understand the paging concept. Actually here what I am saying that a non-contiguous allocation is also called as a virtual memory. Actually, this virtual memory, why we are using, to provide ease to the users and to increase the CPU utilization. How it is increasing the CPU utilization? It's just giving an illusion to the user such that user thought that we are writing a very big program, so that complete big program is stored in the RAM, and there is a space that is allocated to the user is contiguous. So we are just giving its illusion, but in reality only a small portion of the user program is stored. Only the small portion of user program is present in RAM, and that may be contiguous or non-contiguous, whatever it may be, but only the small portion of user program is in RAM, and the remaining program, in this entire program, only small portion is stored in RAM, and the remaining program is stored in secondary memory. So actually that is the concept. Only small program stored in RAM, remaining program is stored in secondary memory. But we thought that the entire program, whatever we are returning, that completely stored in RAM. So now coming to the concept paging. So what here the paging means, and I am talking about this virtual memory, why it is related to this paging. Now let me write that. So here the main memory is divided into number of equal size relatively small frames. So here the process is loaded by loading all its pages into available frames. So let me write that. A computer can add more memory. A computer can add more memory than the amount of physically installed on system. This extra memory is called virtual memory. So in a computer can add more memory than the amount of physically installed. Suppose already we thought that the main memory is the size of the main memory, it can store up to 64 KB. So it can store 64 KB of size of memory. So this is physically installed. We thought that it is physically installed. So a computer can add more memory than the amount of physically memory on system. So it can add more memory. Already physically installed 64 KB. So again I want to add some 64 KB. Okay. So this extra memory you call it as a virtual memory. Actually this is not real. Okay, so this only the 64 KB, whatever it is, the physically installed main memory is 64 KB, and this is an illusion. Here we want to store the temporary data, just it's only whenever the system is off, the whatever the memory that is there, this completely erased and this will be discarded. Okay, so this concept you call it as a virtual memory. A computer can add more memory than the amount of physically installed on the system. This extra memory is called as a virtual memory. It is a memory management technique. So a paging is a memory management technique in which process add space is broken into blocks, broken into blocks of same size, called paging. So this here the memory is there. So this memory in which the process address space is broken into blocks of same size. So this is suppose 8 kilobytes, 8 kilobytes, 8 kilobits, like that. So in which a process address space is broken into blocks of same size. This is called paging. Page 1, page 2, page 3, like that. Okay, so here the size of the size is just the page size is of power of 2. It's always in the size should be power of 2, either 2 or 4, 6, like that, 8, 2, 4, 6, 8, like that. So the paging space, the block size will be always the powers of 2. So the size of process is measured in with the help of number of pages. Always the size of, how can we say that what is the size of the process? The size of process can be measured in number of pages. So suppose here 3 pages are there. So size of the process is 3 pages. The size of process can be measured in number of pages. So similarly, a main memory is divided into small fixed size of blocks. That is the let me write that. Similarly, main memory is divided into small fixed blocks. Small fixed blocks. So that fixed blocks you call it as physically, which is physically you are doing. Means you are not doing that in a virtual memory, you are doing in the physically installed memory. So a main memory is divided into small fixed block physically of fixed blocks of memory. You call it as a frames. So one thing you have to remember that the size of so memory in which the process address space is broken into blocks of same size, you call it as a paging. Whereas a frame means main memory is divided into small fixed blocks of memory called frame. So whatever the data that whatever the division that we are taking place in the main memory, that you call it as a frames, and whatever the division that you are taking in the virtual memory, that is a non-contiguous memory location, that you call it as a paging. So just remember that paging is done in non-contiguous memory location, whereas frames can be done in the main memory. So I'll explain about the paging concept with an example in the next video. Thank you.